Salutations, mini mathematicians! We are getting into it. So, we know so much about simplifying radical expressions that we are going to be getting into sums and differences of square roots. So, we know about simplifying them, we know about multiplying and dividing them. We're going to get into sums and differences, and we like to think about them kind of like terms when we're adding and subtracting. So, I'll talk about what I mean in a second. So our purpose is to completely simplify sums and differences of radical expressions, including using the distributive property and to rationalize the denominator. Okay, so let's get started. So number 1 says, Joy explains to Laura that the expression 3x plus 2y simplifies to 5xy. Is Joy correct? Explain why or why not. Well, sorry, Joy. No, Joy is incorrect. So what would we want to tell Joy besides just she's wrong? We want to explain why, right? We want her to know how to do it right. So 3x and 2y are not like terms. So remember, like terms, when you add them together, we need to have the same variable. Like if we had 3x plus 2x, that would be 5x's. And we also need like the same variable and the same power. So if I had something like 3x squared plus 3x, I can't add those because I need to talk about x squares, not just x's. So we need the same variable and the same power here. So you cannot add like terms. Okay, you cannot add unlike terms. I think I said it wrong a second ago. You have to have like terms to add or subtract. Not true if we are multiplying or dividing. That's why we did that first, because it's a little easier. So then Laura explains to Joy the expression 4 root 5 plus 3 root 5 simplifies to 7 root 10. Is Laura correct? Well, 0 for 2, ladies. 0 for 2. No. And we have to say that using the distributive property, or you can think about this as like with like terms, 4 root 5 plus 3 root 5s is equal to 4 plus 3 root 5s, which is equal to 4 plus 3, which is 7 root 5s. So another note we want to make here is our rule. So to add or subtract radicals, we must have the same number under the radical then add numbers. If you're adding, if you're subtracting, subtract them. Add numbers on the outside. Leave number on the inside. Number on inside unchanged. So we can think about this as like terms or like radicals, because we need to have a like radical. So similarly, if we take a look at our next problem, it says simplify and to show all of our work, we have 2 root 2s and 4 root 2s. If you have 2 root 2s and 4 root 2s, how many root 2s do you have? That's right, 6 root 2s. And I'd like you to show the work of the 2 plus 4 root 2 to get to 6 root 2, or 6 radical 2, or 6 square root 2. It's important to show the work like this for now because it's going to start to get a little more complicated because you can handle it. So let's take a look at the next one. Here, I have 5 root 6 plus, how many root 6 is there if there's no coefficient in front? 1 root 6 minus 2 root 6. Notice all the numbers underneath the radical are samesies. So we can think about this as 5 minus, plus 1 minus 2, all root 6. 5 plus 1 is 6, minus 2 is 4, so this is 4 square root 6. Of course, always double check if your answer is simplified all the way at the end. Square root of 6 has no perfect square factors other than 1, so we're good. Okay, let's take a look at number 5. So I have root 2 plus root 8. Oh no, we don't have the same number under the square roots. There's nothing that we can do. Wrong. We can rewrite them. So always look and see if we can rewrite them. And this is where the fun puzzles come in. So it's kind of telling you, I really want a root 2. Is there any way I can rewrite root 8 to have a root 2? Is there? Well, let's take a look. Just bring down this root 2. Maybe you have square root of 8 memorized. Maybe we want to think about this as square root of 8 is square root of 4 times square root of 2. And of course, you can think about it as root 2 plus square root of 4 is 2 squared times root 2. Square roots and squares are inverse operations. So we have square root of 2 plus 2 root 2. Of course, this is 1 root 2. So now that you have the same number underneath the radical, you have like radicals. We can think about this as 1 plus 2 square root 2, which is equal to our final answer of 3 square root 2, which is in simplest form. Nice. So if you don't have the same number under the radical, look to see if you can rewrite the numbers under the radical to be the same. And sometimes you won't be able to. So if we take a look at 6, notice I have a 2, an 18, and an 8. Always think about maybe trying to make them all with a 2, the smallest one. So go ahead, pause the video, and I want you to finish this page, 6, 7, and 8. Go ahead, pause the video. You're going to finish 6, 7, and 8, and we're going to go over them as soon as you're ready. Okay, let's see how you did. Number 6, you should have gotten 10 square root 2. So remember, if you don't have the same number under the radical, you can rewrite it to make it the same, right? And hint is look at the smallest number under the radical. So we looked at square root of 18, and I know it's 9 times 2. So 9 is 3 squared times square root of 2. The 3 squared, square roots and squares are inverse operations, so they cancel out. So I have 3 square root 2. So I'm happy. 7 square root 2 minus 3 square root 2. Yes! And when I look up at 3 square root 8, I know square root of 8 is 2 root 2. Number on the outside 3 times the new number on the outside 2. Numbers on the outside times numbers on the outside. Simplify, simplify, simplify that radical. So 3 times 2 is 6. So we have 6 root 2. So again, we have 7 root 2 minus 3 root 2 plus 6 root 2. All of them under square root 2. So 7 minus 3 plus 6, we get 10 square root 2. Nice. Okay, so if I take a look at number 7 here, 135. Remember, no calculators. You can grab a basic calculator if you wanted, so you could like double check. Okay, 135 divided by, I don't know what number I want under the radical. There's this 3 here that's giving you a hint, so maybe I want a 3. Yes, 3 works. It's 3 and 45. So use that smaller number because it's helping you out. It's like, hey, try 3. So I tried 3 and it was 45, and 45 I know is 9 and 5. So I pull out the 9, square root of 9 is 3. So I have 3 square root 15 minus 2 square root 3. And you just can't do anything from there. That's as far as you can go. Final answer in simplest form, kaput. Okay, so the last one, number 8. Number 8 is a really cool problem. We have lots of numbers on the outside, and thinking about numbers on the inside, well, all of these square roots can be simplified. So when I first looked at square root of 45, I think 9 times 5. So that 5 was like my big hint there. Square root of 9 times square root of 5. Square root of 9 is 3. Don't forget to multiply by the number waiting on the outside. So I got 18 square root 5. And sometimes I like to do one term and then move on to the next one. So 320, hey, that 5 was my big hint. So I knew it was 64 times 5. I was so happy it ended up being a perfect square times a number. So square root of 64 is 8. And so I have 8 square root 5. And then when I looked at 2 times the square root of 150, again, 5 was my big hint. So I know it's 5 times 30. And if I think about 30, I think of 6 and 5 because I already had this 5 there. So 5 times 5, 5 squared. Square roots and squares are inverse operations. So we end up with 2 times 5 on the outside, root 6. Remember, you have to have the same number under the radical. So root 5 and root 5 are both the same number. 6 is not the same as 5. What? I know, right? Okay. So 10 minus 8, 18 minus 8 is 10. So we have 10 root 5 plus 10 root 6. It's completely simplified. No more you can do there. Okay, let's go and practice a little bit more on the next page. And we're going to talk a little bit more about that distributive property. So we're going to use a distributive property to simplify square root of 2 times 5 plus square root of 8. So remember, this is the square root of 2 times both of these items. So we end up with the square root of 2 times 5 plus the square root of 2 times square root of 8. Remember, numbers on the inside times numbers on the inside, numbers on the outside times numbers on the outside. Simplify, simplify, simplify that radical, right? So here, this is a number on the outside, that's on the inside, so I get 5 square root 2. Plus, these are both on the inside. And if you want to, we can leave them as their factors. I notice already 8 times 2 is 16, and it's a perfect square, so I'm going to multiply them to get 16. So then I have 5 square root 2 plus square root 16 is 4 squared. Square roots and squares are inverse operations. So we get 5 square root 2 plus 4. You can also write it as 4 plus 5 square root 2. Tomato, tomato. Very nice. Okay, so the next question is something that we've been talking about in some of the lessons. And we want to know, is the square root of x plus the square root of 2 all squared equal to x plus 2? Explain why or why not. And because we know that square rooting and squares are inverse operations, they undo each other, but we also have to think about the order of operations that are happening. They have to happen after each other, where here you would have to square roots, and then you would have to add before you squared, meaning they're not next to each other in the order, so they're not going to actually undo each other. So here, the answer is not equal. These are not equal to each other. So order of operations, you would square root, then add, then square, right? Making the square and square root not canceling out. So if we wanted to look at this, we could think about this as square root of x plus square root of 2 all being squared. And we can think about, well, if we expanded that out, that is the square root of x plus square root of 2 times the square root of x plus square root of 2. So another way we can connect it to that area model. So if you had a square that had a side length of x plus 2, would the area be square root of x plus square root of 2 squared? No, it wouldn't. Or if you think about a square, it's not a very good square, with area square root of x plus square root of 2 squared, would its side length be square root of x plus square root of 2? No. So taking a look here, when we do simplify this, we have to do square root of x times square root of x and square root of x times square root of 2 and square root of 2 times square root of x and square root of 2 times square root of 2. So you actually get square root of x squared plus square root of x times square root of 2, square root of 2x. And then we do get that again, square root of 2x, and then square root of 2 times 4, 2 times 2, which is 4. So simplified, this would end up being x plus 2 square root 2x plus 2. which obviously is not the same as x plus 2. So this again is not equal. However, remember, if you have the square root of x plus 2 all being squared, or the square root of x plus 2 being squared, those are both equal to x plus 2 because of thinking about order of operations. Okay, let's keep going. So now we are going to be simplifying and we're going to be rationalizing the denominator when needed. Recall that rationalizing the denominator means you cannot have a square root in the denominator. So let's make a little note about that. Rationalize the denominator. No square root in denominator. Can't have it. It's not simplified all the way. Okay, so let's take a look at 13. So we're simplifying and we're just going to be distributing. I like to circle what I'm distributing. And again, probably not breaking these into factors right away. Into products, leaving them as factors so I can think about smaller numbers. So number on the inside times number on the inside minus number on the inside times number on the inside. Now that we have these, I can break these up to find my pairs. So I know 6 is 3 times 2, and I already have this 3 here. So from here, square root of 3 squared times square root of 2. Pull out the 3 squared, it becomes a 3, and square root of 2 is left on the inside. We're subtracting here. I have this factor of 3, so I'm going to break up this 12 into 3 times 4. And maybe you're already saying, Mrs. Barr, 12 times 3 is 36, and 36 is the perfect square. It's just 6. I'm happy you see that. I didn't see that at first, so I'm just going to keep doing me, So we end up here, 3 squared times 2 squared. Pull out the 3, pull out the 2, ends up being 6. So 3 square root 2, all minus 6. Nice work, mini mathematicians. Okay, let's take a look at 12. So again, looking at this, it doesn't look like we have any distributing. They're just trying to confuse us with some parentheses. So we can use the commutative property of addition, meaning I can change the order since everything's being added. So I'm going to say this is 3 plus 4 plus 2 root 20 plus square root of 45. Okay, so from here, I know 3 plus 4 is 7, and then 2, and then 20, thinking about 20, well, I know it's 4 times 5. Remember, we always want to be thinking about perfect square factors. So if you wanted to grab your calculator, write down your perfect squares on the top, we can be thinking about like, okay, I have 20. What perfect squares go into 20, right? We know like 9 doesn't work in 16 and be like, oh, 4 is a perfect square, you get 5. Okay. So plus 45, ooh, a perfect square, I know, since I have this 5 kind of as my little hint, right? It's going to be left inside. I know this is 5 times 9, or maybe you thought about the perfect square 9 first. So here, 7 plus 2, pull out the 4, square root of 4 is 2, times 5, plus pull out the 9, square root of 9 is 3, root 5. 7 plus 2 times 2 is 4, 4 root 5 plus 3 root 5. Notice you have these root 5s here. So this ends up being 7 plus 4 plus 3 root 5. Nice, nice. And so we can simplify and get our final answer of 7 plus 7 root 5. That's as far as you can go. If you like writing it as 7 root 5 plus 7, be my guest. Tomato, tomato. Pajamas, pajamas. Okay, let's do one more together and then I'll set you free. Okay, so here, okay, you guys, we have a irrational number in the denominator. Ugh, yuck. Look at this. Ugh, ugh, what? That's gross. Ugh. Okay, so what we're gonna do is we are gonna get rid of it. So we want to make it a fancy. We're gonna multiply by a fancy 1. What multiplied by square root of 3 will get rid of the square root? Square root 3. Square roots and squares are inverse operations. So here, if you want to think about this as square root 3 and then put the parentheses 2 plus square root 3, I know I like writing it that way with distributing. I don't really like writing the number I'm distributing on the right. It just looks weird to me. And so this is square root of 3 being squared. Okay, so next step, I'm going to distribute the square root of 3. And when I do that, I'm going to get 2 square root 3, number on the inside, number on the outside. Simplify, simplify, simplify that radical. Plus, I see this as 3 times 3, which is 9, which you know is 3. Or if you just want to write a square root of 3 being squared, you can do that. Square root of 3 being squared in the denominator is 3. Remember, we cannot simplify this 3 with these terms because of this addition. So this is 2 square root 3 plus 3 all over 3. So that is your final answer. There's nothing left you can simplify. If this was also a 3 on the outside, we could simplify all numbers on the outside together, but it's not. It's a 2. So always double check if you can simplify numbers that are all on the outside. Okay, so I'm going to let you finish 14, 15, 16. Go ahead, pause the video now, finish 14, 15, 16, and we'll go over in just a moment. Okay, let's see how you did. So number 14, we are distributing here. Square root of 7 times 2 is 2 root 7. Square root of 7 times 112. Ew, don't multiply 7 times 112. Don't hurt your brain like that. So 112. Well, I have a 7 here. It'd be so cool if 7 went into 112. So just grab your calculator, right? 112 divided by 7, and you're like, ooh, 16, double perfect square madness. So here, 7 times 7 times 16, 7 squared square root, bring out the 7, 4 squared square root, bring out the 4. And these are all being multiplied. And 3 times 7 times 4 is 84. So we have 2 root 7 plus 84. Done. If you want to put 84 plus 2 root 7, go ahead. Taking a looky-loo at 15. So for this problem, I was like, ooh, 192. I don't know what to do with 192. Like it's even. So I looked, oh, 72 is 9 times 8. So maybe 9 or 8 goes into 192. I tried 9 first. Dead end. But then I tried 8 and I was like, yes, 8 times 24, which I was happy about because I know 24 is 3 times 8. Score. So if I worked just with 192, squared 192, 24 times 8. 24 breaks into 3 times 8. 8 times 8, I see that. So I pull out the 8 times 8, turns into 1 8. So 8 root 3. Square root of 72. Remember, you're subtracting all the way down here. So square root of 9 is 3, so I have 3 square root 8. Oh, they tried to trick us with this 8s and 3s switchy swappings. Do not fall for their trickery. Here, 75, square root of 75, 25, perfect square that goes into it. So square root of 75 turns into 5 square root 3. Notice these are our square root 3s. So we end up with 8 square root 3 plus 5 square root 3 minus 3 square root 8. These are the only ones with the same number under the radical, so we can simplify that to 8 plus 5 square root 3, which is 13 square root 3, and then 3 square root 8. I can keep simplifying from there. I probably should have done it up here. Ew, why didn't you see that it's simplified farther, Mrs. Barr? I don't know. I made the biggest mistake of my life. So 4 times 2, pull out the 4, becomes a 2. 3 times 2 is 6. So 13 square root 3, all minus 6 square root 2. Nice. And 16, the last problem on this page, notice we have this 2 square root 9 with the square root 4, and we have the square root 2. We could simplify first before we rationalize the denominator, and that's what I decided to do. I saw square root of 4 is 2, and square root of 9 is 3, so 2 minus the product of 2 and 3 is 2 minus 6, which gets me negative 4. And this looks a lot nicer to rationalize my denominator, so I don't have to worry about distributing. If you rationalize your denominator in the beginning, cool, fine. Just always don't be a math robot, right? Boop, boop, bop, bop. Must do math, must rationalize denominator with multiplying. No, think about simplifying first sometimes. Make it easier on you. Stop overcomplicating things. Okay, so rationalize the denominator, multiply by square root numerator and denominator. Simplify, notice number on the outside, number on the outside. Simplify, simplify, simplify that radical. Negative 2 square root 2, final answer. Notice this negative's on the outside, completely fine. If it was on the inside, ooh, can't take the square roots of negatives. Beautiful work, mini mathematicians. Let's get to this last page. You're like, oh my gosh, the last page, that's when it starts to get difficult. Not for you guys. You're doing a great job. Okay, so I'm going to work on 21 and 22 with you. So 21, we're going to distribute square root of 8. Again, yes, you could simplify square root of 8 first, but I think it's a little simpler leaving it like this. So this ends up with 5 square root 8 minus square root of 8 times 10. Again, leaving it as factors, easier to work with. Okay, 5 times, maybe you've memorized square root of 8 is 2 square root 2 by now, minus, and so in here, I know 8 is 4 times 2, which is cool because 10 is 2 and 5. From here, numbers on the outside, number on the outside, 10 square root 2, simplify, simplify, simplify that radical. Minus, what can I pull out here? Well, I have a 2 squared and a 2 squared and a 5. So I'm going to pull out 2 and 2, and it makes a 4. 4 square root 5. And then you're just done. You're like, I just want to go farther. Just give it a box. You're done. Okay, so taking a look at 22, we have square root of 3 over 100 minus square root of 75. So you can think about this as square root of 75 over 1. Okay, remember, if you have a square root over a whole fraction, that's the square root of the numerator over the square root of the denominator. Okay, so far so good. Any simplifying you want to do? Oh, square root of 100, you're right, that's 10. So now you have 10 over square root 3 minus, we can start thinking about simplifying square root of 75 if you want. So, or we can just leave it as square root of 75 over 1. If you want to keep going, you have to have the same denominator. I cannot subtract unless we have a common denominator. Our common denominator is going to be 10. What do you have to multiply by 1 to get to 10 is 10. Remember, whatever you multiply to the denominator, you multiply by the numerator because we're multiplying by a fancy 1. We're not changing its value. We're just multiplying by 1. So we have square root of 3 over 10 minus 10 square root 75 all over 10. You're like, these 10s cancel out. No, we just did that so we can combine them. Do not cancel them out again. You'll undo all your hard work. Okay, so now we have square root of 3 minus 10 square root 75 all over 10. And you're like, we're done. Almost. If you haven't already simplified square root of 75, we got to do it now. Remember to always double check if your answer is completely simplified. If there's a square root that has a perfect square factor that's not 1, you ain't done. So square root of 3 minus, put a 1 there, 10, and square root of 75 I know is 25 times 3 all over 10. So I'm going to pull out the, sorry, you couldn't see that. Apologies. 1 square root 3 minus, pull out the 25, it becomes a 5. Ooh, square root of 3 madness. So we have 1 square root of 3 minus 50 square root of 3 all over 10. What is 1 minus 50? Remember, I can't cancel out this 50 and this 10 because this subtraction ruins it all. So 1 minus 50 is negative 49. We got the square root of 3, and it's all over 10. Numbers on the outside, no common factors other than 1. Number on the inside, no perfect square factors other than 1. So that's our beautiful answer. Notice I'm writing it as 1 simplified ratio. Nice. Okay, so you are going to finish this page 17, 18, 19, 20, and we're going to go over the answers as soon as you're ready. So go ahead and finish this page, and we will go over them when you're ready. Let's see how you did. Okay, 17. When we're taking a look here, we're distributing square root of 2 to square root of 32 and square root of 10. Leave the numbers as factors, right? So you can break up 32 times 2. 32 is 16 times 2 times 2. So you're noticing 16 is 4 squared, 2 times 2, 2 squared, pull out the 4 and the 2 and you get an 8. Maybe you could have done 32 times 2, 64, but maybe you broke it down. From here, 2 times square root of 2 times square root of 10, we notice that 10 breaks into 2 and 5, so we can pull out one of the 2's and the 5 stays inside. This is 8 plus 2 root 5. You can call it 8 plus 2 root 5, 8 plus 2 square root 5, 8 plus 2 radical 5. Let's take a look at 18. 18, very cool, because since we're distributing the square root of 3, remember, if you're multiplying a square root by itself, just say it's that square root squared. Square roots and squares are inverse operations, and they cancel out. So 4 times 3, 5 times 3, nothing you can do there. Just square root of 15, so we have 12 plus the square root of 15. Don't forget your plus symbol. Awesome, so let's take a look at 19 together. Remember, numbers on the inside multiplied by numbers on the inside, numbers on the outside multiplied by numbers on the outside. Little reminder there. Because this gets a little bit tricky. So 19, when you are rationalizing our denominator here, please take note that I'm only multiplying by the number under the radical, square root of 6. If you multiply by 2 square root 6, you're going to have a lot more simplifying to do at the end. So taking a look here, root 3 times root 6 is root 3 times 6. 9 times root 6 is 9 root 6 being subtracted. That 2 is still there, so 2 times root 6 being squared. From here, we're going to continue to simplify. So I see this 3 here. I'm so happy 6 breaks into 3 times 2. So this 3, I pull it on the outside. 3 square root 2 minus 9 square root 6 all over 2 times 6, which is 12. Don't leave your answer like this, because we have numbers on the outside all having a common factor of 3. So numbers on the outside simplify with numbers on the outside. This is only true for numbers on the outside of our square root. It is not true for numbers on the inside of the square root. So numbers on the outside, 3 goes into 3 once, into 9 3 times, and into 12 4 times. So your final answer is square root of 2 minus 3 square root 6 all over 4. Woo, good job. Okay, let's go over our last problem. So the last problem, we had this whole term being subtracted by this. So I can think about this as -1 being distributed. So we have 5, and we might as well start simplifying since we have the time. Square root of 12 is 4 times 3. Again, -1 times 3 is -3, and -1 times 48 is negative and then square root 48. Notice that negative does not go through the square root symbol, because if I have -1 times square root of 48, this is a number on the outside. This is a number on the inside. They don't multiply together, remember. Numbers on the outside times numbers on the outside. Numbers on the inside times numbers on the inside. Simplify, simplify, simplify that radical. So that's why this is -1 square root 48. The negative does not go through the house. So from here, square root of 16 is 4. I pulled that out. Square root of 4, 2. So don't forget I have a 2 on the outside. 2 times 2 is 4. So we have 5 plus 4 root 3 minus 3 minus 4 root 3. So what I said is I'm like, hey, commutative property of addition. All of these I can rewrite with addition, which helped me out with these negative signs. So 5 plus -3 plus 4 root 3 plus -4 root 3. Rewriting everything with addition really helps me see that, hey, these cancel out, they're opposites, and 5 plus -3 is +2. Nice job, mini mathematicians. Really appreciate all your hard work. You're doing fabulous. Stay psyched, do your best, be nice to everyone, and make it the best day ever. Stay radical.